Hello, grade 10s. We're going to see how Eloise assists Gerard and Segra set up a display in a shop. Eloise helps them see the pattern in the display, and as a result, they do a better job. Let's join them now.
Gerard and Cindy are over at their local supermarket where they work part-time during the holidays. Let's see what they're up to.
I'm gonna put it in between like that. Gerard?
Hi, you two. What are you busy with?
Hi, Eloise.
Hey, we're busy building a promotional display.
Oh, that sounds interesting.
Yeah, it's basically taking turns and stacking them so they can look all fancy and get the attraction of the people walking in.
And we have to stack them in a similar way.
That looks interesting. So what design have you come up with?
It's not so much what we want, but what the floor manager wants. He wants us to stack 50 rows of cans.
That shouldn't be too difficult. Why do you look so frustrated?
It's not as easy as just stacking the tins in 50 rows, but as making a triangle at the same time, where the top row only has 1 can in it, and the next row 3. And in the next row 5 cans, and so on.
I see. So you need to figure out how many cans would be in the bottom row.
Why the bottom row?
Duh, because we can't start from the top. It'll be too much for us to pick up.
Don't worry, I'm sure we can find a solution using what we've learned about number patterns so far.
That's the best idea I've heard all day. Where do we start?
Well, let's start by looking at the cans. Starting from the top of the pile of cans, if we call this top row, row 1, then the number of cans in it is also 1. The next row is row 2, and it has 3 cans in it. The next row is row 3, and it has 5 cans in it. I'm sure you can see a pattern already, but let's check the pattern by adding a 4th row. How many cans do you think are needed in the 4th row? You will need 7 cans in the 4th row. Can you see that we are adding 1 can to each side of the previous row? We could keep adding on the number of cans underneath, but let's use our patterning skills to predict the number of cans in the 50th row. To find a pattern, we need to decide what 2 parts of the pattern to compare and see how they are changing. In other words, we need to identify 2 varying quantities to work with. Then we need to establish a relationship between them that will allow us to predict how many cans need to go in the bottom row. We are going to set up a table of values to help us again. This time I will work with a table across this way. This here is the number of each row of cans. This below it is the number of cans in that row. So far we have seen that row 1 has 1 can. Row 2 has 3 cans. Row 3 has 5 cans. And row 4 has 7 cans.
That just looks like a list of the odd numbers starting at 1.
That's right.
So does that mean if we're really stuck, we could count the first 50 odd numbers?
Yes, I suppose so. The 50th odd number will be the number of cans in the bottom row.
That would be a lot of counting.
That's right. So we want to rather find a pattern that links our 2 variables. So what do you think is the link between the 2 rows of our table? Well, look at the number of cans in a particular row. Do you see that it is always 2 more than the previous row? From 1 to 3, we added 2. Here we added 2, and here we added 2. So it looks like we can find the number of cans in a row by adding 2 to the previous row. Before we go on, let's add a row to the table. This row will be to describe the pattern, the link between the first 2 rows. Row 1 has just 1 can. In row 2, the number of cans is 1 plus 2. In row 3, it is 1 plus 2 plus another 2. I'm going to write that down as 1 plus 2 times 2. Then, in row 4, the number of cans will be 1 plus 2 plus 2 plus 2. I will write that down as 1 plus 3 times 2. Does this give us enough to see the pattern?
It looks like we have a 1 each time. Then we add a multiple of 2 to it.
Let's have a look. If we look at row number 4, here we added 3 times 2. 3 is 1 less than 4. Let's see if the same happens for row 3. Row 3 has the 1 plus 2 times 2. Great! 2 is 1 less than 3. Now think about this. I want to use this pattern for any row number. If I call the row number X, can you find the number of cans in that row? Well, using the pattern, the number of cans will be 1 plus 2 times what? It will be 1 plus 2 times a number 1 less than x. What number is 1 less than x? It is x minus 1. So the number of cans will be 1 plus 2 times x minus 1. We can simplify this to 1 plus 2x minus 2, which is 2x minus 1. In other words, the number of cans is twice the row number minus 1. Now I want to use a second variable instead of saying number of cans. Let's use the variable y to represent the number of cans. That means that we can say that y equals 2x minus 1.
Isn't that a linear equation?
That's right. That is a really important observation, Cindy. We have made a link between number patterns and algebra.
But how does this help us?
Let me show you. If she wants 50 rows of cans, then the bottom row will be the 50th row. So we can replace with 50 in the equation. Then we will get y equals 2 times 50 minus 1, which is 100 minus 1, and that is 99.
Ooh, that's a lot of can. How are we going to be able to stack them without one of them falling?
I don't know, but at least now you have enough information to change the number of rows and still know how many cans need to go in the bottom row.
Yeah, then we can tell the flow manager why stacking 50 rows of cans might not be such a good idea.
Exactly. But I'll leave the explaining to you, Gerard. But whatever it is, we've got to get going. So thanks for your help, Eloise.
Thanks for making this an interesting lesson once again.
Thank you for joining us, grade 10s. Remember to look at the tasks for this section in the Numbers and Patterns tasks video. You'll also be able to learn more on our website, www.mindset.co.za/learn.